Okay, so a couple of people are having a little trouble with this homework question. We're given a template in order to make a box, so we have to find the dimensions of the box that will give the maximum volume. So firstly, let's identify the sides of a box. So we need to identify the size of the box. The box is going to look like this once it's made. We need to identify three sides of the box. This length here, this length here, and this length here. And then we can calculate the volume. So the sides of the box are going to be this length here, which is x, this length here, which is y, and this length here, which will be z. That's z, there's y, there's x. Once we roll this up, we're going to create a box looking like that. So we need to find each of these lengths. Firstly, we've got a constraint equation which we can see here across the top. These lengths here, which is 2 plus x plus y plus x plus y, all have to add up to 36. That gives us that 2x plus 2y is going to equal 34, which means that y is going to equal 17 minus x. So this we can use as a constraint equation given by those dimensions there. Next we can find the length z. So we got another one down in this direction here. So down in this direction we can say that x over 2 plus z plus x over 2 is also going to equal 36. This gives us that z is equal to 36 minus x. So lastly, the volume as a function of x is going to equal x times y times z, which is equal to x times 17 minus x times 36 minus x. Now we've got our formula. We can find the dimensions by graphing it on the graphing calculator and finding the x value that creates the maximum. Okay, so we've got our function and we need to put it into the graphing calculator. So we press Control, add a page, let's add a graph page, and then we type in our function, which is x times bracket 17 minus x, close bracket, times 36 minus x, close bracket. We got a graph like that. We have to adjust the axes now. So we press menu, window, window settings. Right, so this length here, x, this length here, let me just get a pen going. This length here, x, can't be negative because you can't have negative length, so the minimum that x can be is going to be 0. This length here is going to control the domain, the upper limit of the domain. There's no x value can be bigger than 17 because that would make this negative, and that is also not possible. So this one's going to be 17. and then we need to do the y value. So the y value needs to be a much bigger value than 6. So I don't know what it's going to be, but I could just sort of imagine that it might be somewhere in where this face is a bit square. So this face is going to be square at, I don't know, 9, 9. So let's do 9 times 9. And if that's 9, then this is about 28. So I'm going to go a little bit bigger and call it 32. And I get a bigger number, and I can clearly see the full shape of the graph here. It didn't happen at the square point, but close enough it was. And by overdoing it a little bit, I get the axes nicely. Scroll either side of this, and there we go. That is our x value, 7.3. So just over here on this page, we need to have 17 minus 7.3. We need 36 minus 7.3. And there we have the dimensions. So the dimensions required are x equals 7.3, y equals 9.7, z equals 28.7. Obviously, that type of a question on a non-calculated question would have easier numbers to work with. That's clearly a calculator-based question.